Welcome, Calculus BC. This is lesson 4.2, definite integrals, calculating integration, and the fundamental theorem of calculus. Let's begin. So, here's what a definite integral looks like. This shape. And the difference between this and an indefinite is we have something called an upper limit and a lower limit. These are going to be x values. So the way this looks like on a graph is, remember the integral is area under a curve. So I'm going to draw a curve, and then we're going to call this curve f of x. Well, A is your lower value of x, and B is some upper value of x. So this represents the area under the curve between A and B, and it would shade in all of this. When I say under the curve, it's the area between the curve, or the function, and the x-axis. So another thing with definite integrals is they give a number, like 5. It equals a number. Where indefinite integrals, sometimes we had a function with x's and we did the plus c. So the integral of x squared was x cubed over 3 plus c. So you're going to always come out with a number. You won't have x's left over if you have numbers up here. So I want to show you how this works in a calculator. Let's say I wanted to integrate x cubed minus 6x. So what does that graph look like? Well, let's look over at the graphing calculator. I'm going to type this in and go x cubed minus 6x. And then we're going to look at the graph. So here we go. And it looks like this cubic equation. You know it's cubic because the x cubed is the highest term, and you see what's going on there. Well, I want to integrate, I want to figure out what the area is under the curve. And I have this neat function I want to show you. You go under math, when you're in a graphing mode, and there's this integral f of x dx. This will shade in my area under the curve. So I'm going to go my lower limit's -3, upper limit's 1, and it'll shade in the area under the curve. So it shaded this area, which would be negative area. This would be positive, and this would be negative area. And it says this all adds up to 4. So if I go back to here, my answer should be 4. Why is my pen being weird? My answer should be 4. So let's see how to do this in a calculator without graphing it. So what you want to do is there's a function called, under calc, there's something called n integration. And I'm doing this on an 89, but you can find it on your 84s. X cubed, and there's easier ways to do this on an 89, but this way works too. Comma x, and you're going to comma your lower value, comma upper value. This is one of the 4 things you need to do on calculus for the AP test. And notice this does integration of that function, and 4 is my answer. So there's the format. You do the variable, then the lower limit, then the upper, and boom, 4. And that's my answer. All right, another thing, I might want to show how to set up a definite integration based off a picture. So looking at this picture, this is my shaded region. My lower bound's 0 and the upper bound's 2, and the function it's being shaded under is this function right here. So setting it up would look like the integral from 0 to 2 of 2x squared minus 3x plus 2 dx. And there I go, and I could integrate from there if I wanted to. All right. We're going to do a little bit of discovery here. So we have this function, we're going to call f prime of x is this line right here. So I want to find the integral from 0 to 5 of f prime of x. So that means the area under the curve of f prime of x from 0 to 5. And if you look what I have to shade in, it forms a shape, which looks like a rectangle. And the height of the rectangle is 3 and the length is 5. So the area, or the integration right here, is going to be 3 times 5, which is 15. That's the area under the curve. Now, let's say I want to write an equation for f prime of x on 0 to 5. So what's an equation of this line? Notice that it's a horizontal line at 3, so I can say my equation is y equals 3. Or we can say, f of x equals 3 as an equation too. All right, now f prime of x, excuse me. So find f of x if f of 1 equals 4. So I know f prime of x is 3. That means I need to integrate 3 dx. And so that's going to get 3x plus c. That means my f of x equals 3x plus c. So I got to figure out my c. Well, I can use this f of 1 is 4 to figure out my c. And say 4 equals 3 times 1 plus c, c's. So 4 equals 3 plus c. And that means my c equals -1 or positive 1. So f of x is 3x plus 1. Now, find f of 5 minus f of 0. So f of 5, if my equation f of x is 3x plus 1, f of 5 is going to equal 3 times 5 plus 1, which is 16. And f of 0 would be 3 times 0 plus 1, which is 1. So if you subtract those, 16 minus 1 is 15. And hey, that's f of 5 minus f of 0 is 15, and also the integration was 15. What a coincidence. So the integration of the derivative is just the difference between the right limit minus the left limit. And that creates a formula. So we call this the fundamental theorem of calculus, which is basically just definite integration. We did this last year. So you integrate your function, and then you plug in your upper limit minus plug in the lower limit. Let's take our example from before in the calculators. We know the answer is 4. So if you integrate that, integral antiderivative of x cubed is x to the 4th over 4 minus 6x squared over 2. And don't say plus c. Write your limit as negative 3 to 1. Now that 6 over 2, I can just reduce that to 3. So I'm going to do that. So now I'm going to plug in 1 for the variables first. So it'll be 1 to the 4th over 4 minus 3 times 1 squared over nothing. And then minus plugging in negative 3. So negative 3 to the 4th over 4 minus 3 times negative 3 squared. All right, let's clean this up just to prove this. So it's going to be 1 to the 4th is just 1, so 1/4 minus 3 be minus 3 to the 4th power is going to be 81 over 4 minus 3 squared is 9, so it'll be minus 27. Distribute that negative sign, it'll be negative 81 over 4 plus 27 minus 3 and positive 1/4. Combining the 81 and the 1/4 becomes negative 80/4. Negative 3 plus 27 is going to be plus 24. 80 over 4 is negative 20 plus 24, which is just 4. And that was the same answer we got before. Cool. All right. So I can try another one just as an example. Now, I got to integrate this. And you're like, you have to use u substitution here. So my u is 4t plus 1. And that means our du is 4 dx or dt. Now, there's a few ways we can approach this. I'm going to just teach you my way. So I'm going to create that 4. And I'm also going to divide by 4 on the outside. So it's going to be 1/4 the integral of u to the 5th. Now, sometimes what they'll do is convert these limits to the u limits here, but we're not going to do that. I don't like that. I'll show that to you later in class. So antiderivative of u to the 5th is u to the 6 over 6 times 1/4. Now I'm going to plug in the u back in. So it'll be 1/4 times 4t plus 1 to the 6 over 6. And the limits are from 0 to 1. All right, so plugging in, and this is 4 times 6. I'm not going to write this mess. It's just 24 on the bottom. All right, so plug in 1 first. You're going to get 4 times 1, or 4, plus 1 to the 6 over 24, minus 4 times 0, which is going to be just 1 to the 6 for 24. So 5 to the 6th power, which is going to be 5 to the 6th power over 24 minus 1 over 24. And so 5 to the 6th minus 1 over 24 is your answer. Not going to do that. Just leaving it. All right. So another thing you can think about is, since the integral, or the first fundamental theorem of calculus is this, we could rearrange this and say f of b is f of a plus the integral. And this might be useful if you want to figure out, like, if you know where you were at the start and you want to figure out how much you've accumulated at the end. So maybe a different way of writing the formula. So, and this is useful in this kind of problem. So if f prime of x is this and f of 0 is 4, and find f of 2. Now, you don't have to, you could leave it in this format, but maybe this format makes more sense to you. So in this case, my lower limit, my a, would be 0, and my b in this case is 2, and I want to find f of 2. So basically, I want to find this thing. All right, so I'm just going to rearrange in this format. So that means my f of 2 could equal my f of 0 plus the integral from 0 to 2 of f prime of x. So 3x squared plus 3 dx. And again, I didn't really need to rearrange in this format. I could have solved anyway, but here we go. We know this equals 4, and then you're going to integrate this guy. So it's going to be integral of 3x squared is just going to be 3x cubed over 3, just x cubed plus 3x from 0 to 2. I'm going to ignore this 4 per now. So I'll plug in the 2 first. It's going to be 2 cubed plus 3 times 2 minus plugging in 0 is going to be 0 cubed plus 3 times 0, which goes away. So this is just 8 plus 6, and this plus 4, and it adds up to 18. So there's your answer. All right, we're done.